Okay, so today we're going to talk about the discriminant. Okay, so it says to describe each as either real or imaginary. Remember, imaginary, you have to have an I, negative under the radical. And then, if you can, tell me if it's rational or irrational. So let's take a look at number one. So you put me on pause and then give it a try and then come back. All right, so we have the square root of negative 9. So the square root of negative 9 is 3i, so that's imaginary. The square root of 75. So I can't take the square root of 75 because it's not a perfect square. So that means it's irrational. So it's real. And real meaning, what real means, it's on our number line. So I know I can't take the square root of 75, but I know it's approximately some number. Okay, so it's real and it's irrational because I can't take the square root of 75. If I plug in the calculator, I'll just get a decimal that goes on forever. So the square root of negative 2 is imaginary. Right, because remember that's square root of 2i. That's square root of 2i because it's a negative. And then we have the square root of 4. Now the square root of 4 is 2, so that is real. And that's rational. Remember, rational number is any number that can be written as a fraction. All right, so what I want to do now, and this is going to take us some time, so this video is probably going to be a little on the longer end. We are going to solve 4 quadratics here using the quadratic formula. Okay, so let me write down the quadratic formula so everyone has it on their paper. Okay, so write it right above here. All right, so that's x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So I'm going to solve all these quadratics using the quadratic formula. All right, so it's going to be a little long. All right, so let's start. So over here I have a is 1, b is negative 2, and c is negative 3. All right, so I have x is equal to 2 plus minus the square root of negative 2 squared minus 4 times 1 times negative 3 over 2 times 1. Okay, so I get x equals 2 plus minus the square root, plug in what's under the radical, we get 16 over 2. X equals 2 plus minus the square root of 16 is 4 over 2. So now I can actually finish this up because this is not irrational. So I'm going to break it apart. 2 plus 4 over 2. So that's 6 over 2, which is 3. And then I have 2 minus 4 over 2, which is negative 2 over 2, which is negative 1. Okay, so this is what I want you to take a look at. Is that notice the number underneath my radical is a perfect square. So write that down. Perfect square. And then my answers, my roots, my zeros, my solutions, they are real, they are rational, and they're 2 different ones, so they are unequal. Okay, so when I have a perfect square, I get real, rational, unequal roots. Okay, so let's try the next one. So I have A is 1, B is negative 6, and C is 7. So I get x equals 6 plus minus the square root of negative 6 squared minus 4 times 1 times 7 over 2 times 1. So I get x equals 6 plus minus the square root of 8 over 2. Now I could simplify the square root of 8. The square root of 8 simplifies to the square root of 4 and the square root of 2. That's 2, which is 2 the square root of 2. So I get x equals 6 plus minus 2 the square root of 2 over 2. And then I can reduce, right? I can simplify here. So that becomes x equals 3 plus minus the square root of 2. So I have 2 roots, 3 plus the square root of 2. And x equals 3 minus the square root of 2. So now this is what I want you to look at. Look at what's underneath my radical. It's something that's not a perfect square. And let me just write this a little bit neater. So not perfect square. And then I want you to take a look at the roots. Notice that my roots both have radical 2 in it. That's an irrational number. So they are real, irrational, and they're two different because one's plus radical 2, one's minus the square root of 2. So they are unequal. All right, let's try number 3. Let's try number 3. So we have A is 1, B is negative 4, and C is 4. We get x equals 4 plus minus the square root of negative 4 squared minus 4 times 1 times 4 over 2 times 1. So I get x equals 4 plus minus the square root of 0 over 2. And then the square root of 0, the square root of 0 is 0. So it's x equals 4 plus minus 0 over 2. So we can split that up. Split it up. We get x equals 4 plus 0 over 2, which is 4 over 2, which is 2. And then the same thing, x equals 4 minus 0 over 2. Got to move this up a tiny bit. So it's 4 minus 0 over 2. So it's 4 over 2, which is 2. Okay, so notice what's under the radical. Underneath my radical, I had 0. And then notice what I have about my roots. My roots are exactly the same. I get 2 of the same roots. So that's real, they are rational, and they are equal. So remember, when you get a 0 on the radical, you get equal roots. Okay, let's try the last one. A is 1, B is negative 4, C is 5. So we get x equals 4 plus minus the square root of negative 4 squared minus 4 times 1 times 5 over 2 times 1. X equals 4 plus minus the square root of negative 4 over 2. So x equals 4 plus minus 2i over 2. That's an I in here. 2i over 2. And we can simplify. Right? We can make our heart here. So we get x equals 2 plus minus I. So notice that underneath my radical, I had a negative. And look at what kind of roots I had. Well, I had imaginary roots. So anytime you get a negative underneath the radical, it's imaginary roots. So let's just review this. When I get a perfect square under the radical, I get real, rational, unequal roots. When I have something that's not a perfect square, I get real, irrational, unequal. That makes sense because you can't take the square root of a number, so it has to be irrational. When you get a 0, think about it. You're adding 0 to a number and taking it away from a number. You have to get the same exact numbers. That's why they're equal. And when you get a negative under the radical, this one's easy. Anytime you get a negative under the radical, it's an imaginary number. Okay, so let's go to the back. We're going to fill in a chart, make a whole nice big chart, nice and pretty. All right, so flip it over. Okay, so the discriminant is what is under the radical. Remember, I was circling those numbers. It was only the only number that I circled is what was under the radical. So let's write that down. The discriminant is the number under. Oh, so I forgot the number. The number. Oh, sorry. The number under the radical in the quadratic formula. Okay, so what is under the radical in the quadratic formula? That is b squared minus 4ac. So that's our formula for the discriminant. It's what's under the radical. Okay, so we're going to make a chart. I'm just going to move everything up. Okay, so we're going to start with the discriminant. All right, so when my discriminant, b squared minus 4ac, is greater than 0, which means it's positive, and it's a perfect square. My roots, so think about it. You have a number. Think about the quadratic formula. A number plus minus a perfect square. Square root of perfect, like 4 over a number. They will be real. They will be rational, because you could take the square root of it. and they will be unequal. Because you're adding 2 and subtracting 2, you're going to get 2 different numbers. Now, on the graph, your graph will cross the x-axis 2 times. At 2 specific numbers, like -2 and 2. So let's put down crosses x-axis 2 times. Okay, next one. When b squared minus 4ac is, not less than, greater than 0, but it's not a perfect square. So it's positive, but not a perfect square. So think about it. You have a number, plus, minus, pick a number, square root of 5 over a number. Doesn't matter what those other numbers are. Okay? So they will be real. It means it's on the number line. It is irrational. You can't take the square root of it. Irrational. That's the key word for this one. And unequal. Okay, so now on your graph, it will also cross the x-axis 2 times. And this can either open up or down. It doesn't have to be just like that. But it's going to cross at like decimals. Like it'll be in between numbers. So to like be, if this is -2 and this is 1, this would be 1, -1 there, 1 and 2. It's going to cross in between the tick marks because it's irrational. It's a decimal that goes on forever. Okay, but you could put down crosses x-axis 2 times. Okay, so next one. When b squared minus 4ac is equal to 0. So think about it. A number plus minus the square root of 0 over a number. So they are real. They are rational because you could take the square root of 0. Now think about this. You have a number plus 0, a number minus 0. You're going to get the same exact number. So they will be equal. And then on your graph, and of course, this could open up or down. It doesn't mean it has to open up. I'm just drawing them up. It means it hits the x-axis 1 time. Touches x-axis 1 time. And you should remember from geometry, when you had a circle and a line, and a line hits a circle at 1 time, it's called tangent. So this can also be called tangent to the x-axis. All right, last one. When b squared, this is the easy one. B squared minus 4ac is less than 0, meaning it's negative. So think about it. You have a number plus minus the square root. Doesn't matter what number it is as long as it's negative. -3 over a number. So what is this? When you have a negative under the radical, it's imaginary. Now, what does the graph look like? The graph will either open up like this. It'll be above or below the x-axis. It will not touch the x-axis. It can't touch the x-axis because the x-axis is a number line. So it can't possibly touch the x-axis because they're not real. The number line are real numbers. So it has to be above or below the x-axis. So put entirely above or below x-axis. Okay, so now let's try some problems. So I'm just going to move everything up. Okay, so it says find the discriminant and determine the nature of the roots. What it means by determine the nature of the roots, it means describe the roots. Are they real, rational, equal, imaginary, etc. Okay, so remember the discriminant is b squared minus 4ac. That's all we have to do. We don't have to do the whole thing. So my a is 1, b is 6, c is 2. So it's 6 squared minus 4 times 1 times 2. So just plug that into the calculator. And we get 28. So think about it. You have the square root of 28. Think about the square. That's the discriminant, 28. But think about the square root of 28. That is real. Can't take the square root of 28, so it's irrational. And they are unequal. All right, let's try 2. So a is 1, b is -4, c is 2. So it's -4 squared minus 4 times 1 times 2. Plug that in your calculator, and you get 0. So think about it. A number plus minus the square root of 0 over a number. That is real. That is rational because you could take the square root of 0, it's 0. And think about it. You're adding 0 and subtracting 0 from a number. That is going to give you equal roots. Okay, let's try 3. A is 1, B is 10, C is 9. So it's 10 squared, 10 squared minus 4 times 1 times 9. Plug that in your calculator, and you get 64. So think about it. A number plus minus the square root of 64 over a number. So that is real. You could take the square root of 64, so that means it's rational. You get 8. So you're adding 8 and subtracting 8 from this number here. So that means they will be unequal. Okay, and the last one. A is 1, B is 2, C is 6. So it's 2 squared minus 4 times 1 times 6. So just plug that in your calculator, you get negative 20. So think about it, a number plus minus the square root of negative 20. This one should be easy, because when you get a negative under the radical, it's imaginary. Okay, so that's it, and we'll practice more in class tomorrow. Have a good night.